Welcome to Mickey's Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes using the Solid Edge software. Coming to the problem statement. The top view of a square lamina of side 30 mm is a rectangle of sides 30 mm cross 20 mm with the longer edge of the rectangle being parallel to both HP and VP. Draw the top and front views of the square lamina. What is the inclination of the surface of the lamina with respect to HP and VP? So, looking at the problem statement, we can make a set of conclusions. That is, in the initial position, it is a square lamina of side 30 mm, and when it is inclined with the HP, it is going to appear as a rectangle of sides 30 mm cross 20 mm, with the longer edge of the rectangle being parallel to both HP and VP. So this data should be used for the inclination of this particular lamina in the third position. That is, the edge on which it is resting on HP in the initial condition, the same edge must be parallel to both the HP and VP. So, looking at the problem statement, we can come to a conclusion that the square lamina is resting on one of its edges on the HP. Only in that condition, two of its edges can be parallel to both HP and VP. So, this is the conclusions that we can arrive before we start solving the problem. And also, the question asks us to detail about the inclination of the surface of the lamina with respect to HP and VP. So we can just have the profile view, that is the side profile view of this particular square lamina, and then determine the inclination with respect to HP and VP. So we shall start solving the problem by drawing the XY line of thickness 0.18 mm. So we shall draw a line of any arbitrary length and annotate this line as X and Y, and the reference planes as VP and HP. So now we will draw the top view of the square in such a way that two of its edges are parallel to both HP and VP. So here he tells that in the third position, the longer edge of the rectangle is being parallel to the HP. So we have to understand that the longer edge measures 30 mm, and hence the square should also have a side of 30 mm in its initial position, even if this data is not given. So we shall draw a square of side 30 mm. So this is the top view of the square lamina. So we shall annotate this square lamina as A, B, C and D. So this is the top view of the square lamina. Now let us draft its front view by drawing the projectors from each of the corners. So let us select the projection line of thickness 0.13 mm and draw the projection lines from B to A, intersect the reference line, and then C to D intersect the reference line. So the reason why the projection lines are intersecting the XY line is it is resting on HP and it is not above HP at any particular distance. It is on HP, so the front view will be exactly on the reference line, which is the intersection of both VP and HP. So now we will trim this part and draw the front view of the square lamina by using a line of thickness 0.50 mm. So from this endpoint to this endpoint, now we shall annotate the front view of the square lamina as B dash inside the bracket A dash, because to the observer, first the corner B is visible and A is superimposed behind the corner B, and here this is C prime or C dash outside the bracket and D dash inside the bracket. So this is the front view of the square lamina. So now coming to the second position, the inclination with respect to the HP is not given, but however the data has been given with respect to the top view. So he tells that this square is going to appear as a rectangle of side 30 mm cross 20 mm, okay, in the second position. So what we will do is we shall draw the top view of this rectangle by selecting a continuous line of thickness 0.50 mm, and here the longer side should be having the dimension of 30 mm and the shorter side must be 20 mm. So this is what is the data given to us. So now we will complete the rectangle at any arbitrary distance towards the right hand side of the XY line, and then we will draw the front view of this by choosing a continuous line of thickness 0.13 mm So we shall intersect the xy line. So we will just take up this projection lines to some distance above the xy line, and now we do know that the square is going to measure 30 mm in its top view, and this will also be equal to 30 mm in the front view. So now what we can do is we can draw the front view of the square lamina from this point to this point, measuring 30 mm, which is intersecting the projection lines of both the extreme edges of the rectangle in the second position. So this is what is the line. So you can just see that it is measuring 30 mm. So coming to the inclination with respect to the HP is 48 degrees. So now we can just use the trim option and trim these projection lines, which were the extension. So now we will annotate this. So this is B dash, A dash, or you can even measure this, and then keeping this as the point of center, cut an arc on this projection line and then transfer that line. So C dash, D dash is the second corner point. So now we will annotate the top view also as A, B, C, and D. So this completes the second position. But however, with respect to the next position, that is with respect to the VP, he tells that the edge on which it is resting is parallel to both HP and VP. So you can just see that this edge AB is parallel to the HP in the initial position. Now it has to be parallel to the vertical plane as per the problem statement. So he tells that with the longer edge of the rectangle being parallel to both HP and VP. So here the longer edge is 30 mm. So it is a square measuring all the sides will be equal to 30 mm, and here the longer side is 30 mm. So now this longer side should be parallel to VP. So for that purpose, I'll go select the second position of the square, which appears to be a rectangle of 30 cross 20, and then select the move option and ensure the copy is on. Keeping A as the point of reference, I'll just move this rectangle towards the right hand side of the XY line. And next, I'll select the rotate option and ensure the copy is off. So now I'll rotate the rectangle in such a way that the edge AB is parallel to VP. So we can just move this towards the left side so that we'll be having sufficient space to draw the side profile view. So now we will draw the projection lines of thickness 0.13 mm. So this is in the vertical plane. Now we shall intersect this projection line from the horizontal plane, and this is the square in the front view in the third position. So we'll complete that. So we will select the line of thickness 0.50 mm, and this is the end point of this line. So point of intersection. Next is again the second point of intersection, and then complete the rectangle. So now we will select the annotation and then annotate this view of the rectangle as C dash, and this is D dash, and this is B dash, and this corner is A dash. Correct? So this completes the problem. But however, there is a question asking to determine the inclination with respect to the VP. So with respect to the HP, we know that 48 degrees is the inclination. In order to determine the inclination with respect to the VP, we'll just draw the profile view of this lamina, either the left profile view or the right profile view. So the most convenient is the left side view on the right profile plane. So we can do that by drawing a xy or x1 y1 line of thickness 0.18 mm. So I will annotate this line as x1 y1. So this is x1 and this is y1. So this plane, I do get here the intersection will be the right profile plane and the view will be the left side view. So for that, let me draw the median line of 45 degree inclination. So enter the angle of inclination as minus 45. So now we shall draw the profile view. So to get the profile view, let me just draw the projection line extending from the front view, and then so this is A and B projection line intersecting the xy line, which is also having the locus of the corners A and B, and then from D and C intersect the median line and then extend it until it is intersecting the locus of the line of the corners C and D. Correct? So now we shall draw the side view of the square lamina. So it will be from B dash B double dash A double dash to C double dash D double dash. So we will annotate the profile view also. So this is the side profile view, which is C double dash inside the bracket D double dash. So all this must be in small letters. So I'll be using the double prime for annotating the side view of the square lamina. And this is uh, B double prime and A double prime. Okay. So now you can just see that the inclination with respect to the VP and HP can be measured. So now we will go for the angle between, and this is 48 degrees, which is the inclination with respect to the HP. And to get the inclination with respect to the VP, we can just draw the construction line from this point, and then okay, let the thickness of the construction line be 0.13, and then measure the angle between this side profile view and the construction line, and the angle is 42 degrees. So with respect to the VP, the inclination is 42 degrees, and with respect to the HP, the inclination will be equal to 48 degrees. So we shall draw the indications of the projection lines using the leader option. So these were drawn upwards, and this projection line was downwards, and again these were all drawn upwards. Okay, so this completes the problem. So to summarize, there is a square lamina resting on one of its longer edges, okay, being parallel to both HP and VP. So since it is a square lamina, all the edges will be of the same dimension, that is 30 mm, and here that edge is AB, which is parallel to the horizontal plane. And in the next position, the edge A dash B dash is parallel to the vertical plane as well. So this is the front view of the rectangle, which is appearing to be a rectangle of 30 mm cross 20 mm. So we better show the dimension of the rectangle in the second position. So this is 30 cross 20, and here it is AB, which is parallel to HP, and AB, which is parallel to the VP. So this is the corresponding front top view, and this is the corresponding front view of the square lamina as per the given conditions. So this is the angle of inclination with respect to the VP, and this is the angle of inclination with respect to the HP. So the median line angle also must be shown. So this is equal to 45 degrees. With this, we complete the problem. Thank you all for watching.